Hey everybody, my name is Stephen Feuerstein. I'm the developer advocate for PL SQL at Oracle Corporation, and I'm very pleased to introduce to you Beda Hammerschmidt, who is the developer of the Oracle JSON functionality, an Oracle database. And he's here to share with us his ideas on how to use JSON documents to implement Flexfields in an extremely elegant fashion. Take it away, Beda.
Welcome to the JSON Ask Tom session. My name is Beda Hammerschmidt. I work as a developer in the JSON team, been around there for 10 years or so. Before that, it was XML. And I also see Drew Adams on the line. He's our doc writer. If this is not another Drew Adams by any chance, but I think it is. Drew, you want to say hi? He's too shy. So yes, now I will talk a bit about how our customers use JSON, and one common use case is to use JSON as a means of providing flexible fields. So for this example, which is available on Live SQL, so you can play with it yourself, we're gonna create the emp table. As an alternative, you can just log in with Scott Tiger and you see the emp table already present. So the emp table is a classical relational design where you have columns representing properties regarding an employee. So an employee has a name and a job and a hire date, the salary, so on. And in statement 2, we're just going to insert the sample values that come already in the Scott Tiger schema. So for example, there is an employee with number 7934. This employee's name is Miller, and Miller is a clerk. So now let's say we have an application running using this emp table, and later on we realize we need additional information for an employee. One example might be the shoe size. So the normal relational approach here is that you just add a column called shoe size. In our case, it's a number, but this is actually quite invasive. So first of all, it requires DBA, and then some queries may have to change. So for example, if you have a select star query or some other queries, they all need to be modified to transport this new information, this shoe size, to the application in the mid-tier, for example. So this may actually mean some downtime. So what customers typically do is, instead of adding columns as they're needed, they do this up front. So they may add 10 varchar columns or 10 number columns, and they would be called number 1 to number 10. And maybe date 1 to date 5 and timestamp 1 to timestamp 5. And as they need a new field to store some properties, they may just pick one of the remaining unused flex fields. So they could say, well, shoe size, that's number 3 column. And this is obviously not a very meaningful name. So somewhere now you have to write a comment that number 3 is actually the shoe size. Sometimes you also run out of these fields, so you may realize if you have sparse fields that some employees have shoe size in number 3, but some other people have another value in number 3. So this becomes all very cumbersome and complex. So people have looked for other means to solve this problem. So now we're going to drop our shoe size column. We don't want to go this route. Instead, we create another column to store JSON. So I call this column flex. Flex is a CLUB column. We could also choose this to be a BLUB or a varchar2 column. Varchar2 obviously up to 32K characters. And we give a hint here that the flex column is a JSON column. So this means we tell the database that all the data that resides in this column will be JSON. So now we can query this flex column already. We haven't inserted anything, but because it's a JSON column, we can actually look inside using a simple dot. So in our select here, we say select the flex column, and inside look for shoe size. And what we see is that all the shoe sizes are null, obviously, because there is no data inside here. Same is obviously true if we look for other flex fields here. So let's insert something. This is an update operation where we set flex to XYZ for employee 7934. But because XYZ is not JSON, the database just rejects this insert and tells us, well, this is not JSON. I am not executing this update. So let's insert some real JSON data here. So for the same employee, we add a JSON object. This is the JSON object starting with these curly brackets. And now we have a field called shoe size. Its value is 12, so this is a numeric value. And we add another field called skills. Its value is an array of several items, and the first item is Oracle, and the second one is C. So the update succeeds because this is valid JSON data. We do the same for another employee who has slightly smaller shoes. And now we can query it. So we repeat the query here. And surprisingly, we get also only null values back. Why is this? So if you look carefully, you see that shoe size here is all in lowercase letters, whereas in our JSON, it's uppercase. So here we have an auto case sensitive field names. So if we correct this to an uppercase S, we will see that shoe size returns two numeric values for those rows where we have inserted those. Similarly, if we query for our skills, e.flex.skills, we do get back the two rows or the two column values for those rows where the flex fields are present. Now we see that this is an array. It has two values, hiring and firing. So with our path expressions here, we can also give an array offset, or we want the first skill here. So we will get back hiring and Oracle. This could also be a 1 or a 2. Obviously for 2, we would get back Java, and this one has no third element. So this starts, unlike SQL, this is more JavaScript motivated. So the first array item has the position 0. Now what we can do is we can expose this JSON data just as relational data using a view. So I'm just creating a view here, emv1, where I select some relational columns as well as some fields out of my JSON data. And now when I want to query this view, I can just access these field names as if they were plain relational fields. And I get this one back. What we observe here is that our skills value is an array or a list of items. So this makes it hard to compare it. If we want to look for people whose skill is C, then we may be able to do like a contains query or a substr equals, but this is quite hard. How can we expose C and Java and Oracle as standalone values? Well, for this, we use JSON table. So JSON table takes our JSON as an input, and it takes a path expression. In this case, it's $.skills square bracket star. What does this mean? Well, it means go to the document, then go to the skills value, which is an array, and the wildcard or the star here means iterate over each values inside this array. And then for each value, the column clause here tells us project out the value you find inside the array item. So in this case, we want to expose this as a value or a column named skill. Its data type, it's a varchar 20, and the path means take the value as is, don't go further into it. So as a result, we will see here on the right side a new column called skill, and we see all the values that were in the array, hiring, firing, Oracle, C, Java, as separate column values. So now it is possible to do an equality where we can say where skill equals C or where skill equals Java. So now JSON table is a row source, which means that for one input value, it can generate multiple output values. And we see here that this is the case for 7934, for example, which was one input Miller. And because Miller has multiple skills, we see all the other values being repeated. So the employee number is repeated, the name is repeated, and the job is repeated. What we also see in this result is that all the rows are missing where flex is null. And to also get these values, we just have to replace our JSON table here with an outer join. So this is the only difference here. This allows us to basically see the entire table. So for example, King has no skills and no shoe size, but we still see it because this is a left outer join. As an alternative, what we show later, we could also have an empty array as a flex field column value. Then we wouldn't need this left outer join game here. So again, if we turn this query into a view, so this is the exact same query, we just do a create view on top, then we can query our JSON data plainly relationally. So we can say where skill equals Oracle. So at this point, all the JSON-ness of this example is gone. This looks and feels like a plain relational use case. Now, there are cases where you want to do more complex operations with your JSON, where you want to look into several fields, or where you want to look and do some business logic. For this, we added some support in PL SQL. I'm just covering the very surface here. I wrote a function here called getField, and the input is our flex column, and we provide in the name of a field that we're interested in. And what we do is quite easy. So if our input is null, then we also return null. Obviously, if there's no input, then there won't be any output. Then we just turn our flex JSON into an in-memory JSON object. So now the JSON is in memory, and we can do various things. In this example, we just extract the value of the field called that's passed in as a name, and we get the value as a string and return it. So for example, we can invoke getField with our flex field and shoe size, and we will get back this result here. Obviously, PL SQL has a lot more operations here, so now you could do if then else calculations, etc., so on. Another usage of PL SQL is to perform updates. So as of 12.2, we don't have a JSON update operator, but we can use PL SQL to set a specific field. So I wrote this function setField. Again, it takes our flex field as an input and then a name value pair, and it returns the updated result. So this actually should be a CLOP here, not a varchar, but that doesn't matter for this example. So again, if our input is null, we generate a new JSON object. So this would be an empty object with nothing inside. So this allows us to turn all those rows where flex is null into a JSON object, which doesn't contain anything. If flex is present, then we parse it, and now we have an in-memory representation of the same value. We then just do a put operation where we set the name value combination and serialize it back to a string and return it. So for example here, we can do the update operation on our flex field, and we set a field flex and give it the empno as an example. So now with a little bit of magic, we added statement 26, which is just select start from end. And you see as the result of our update operation with a set field ID and empno that all our flex field columns do have a value. So null has been replaced with a JSON object, and the ID value has been taken basically from our empno. So the empno is here. And for those values that had already a flex value here, the ID got added. So we didn't overwrite anything. Instead, those values were preserved. And customers use this to add dozens, if not hundreds, of flex columns to their data. And the reasons are, well, there are at least two reasons. One is that they may have frequent changes. And another use case we've seen is that they allow other groups or partner companies to augment their data so they don't know what columns people may want to have. So this is, those are both cases where JSON helps a lot to gain this flexibility in schema design.
Thanks, Beda, for that demonstration of using JSON documents as a very elegant and simple implementation of flex fields inside a relational framework. Now let's check out some Q&A on the topic.
Can we add an attachment? You mean as a field value?
That sounds right.
So JSON's data type are quite limited. They have strings, numbers, booleans, and then nested object arrays and the value null. So if you can encode your document as a huge long string, yes, you could embed it. But I don't think this is a very good idea, and I don't know of anyone really doing it. So normally if you have attachments or binary files, maybe another use case, Word file would be one example. Another example would be if we wanted to add a photo to our employees. Let's say we wanted to set up an intranet pages of our employees like we have at Oracle, and if you click on one, you don't only see the data but also a picture. How would we model this in JSON? And I think what people typically do is they have a separate table, sometimes file system, where they store the binary files, which is associated with an ID. And then the JSON data would contain the ID. This would also mean that fetching such a JSON would be a lot faster because you only fetch the binary files on demand once you need them. So think of having a file with attachment. The question is, will the user who opens such a JSON always want all attachments? So does it make sense to ship them all together? And I think the typical answer is no. So you might be better off just having your JSON with the data and metadata pointing to the other files, the attachments that you can load then on demand.
And I've got two other questions here. One is, will there be more sessions on JSON? You bet we're doing these once a month.
Right. Yeah.
More questions. And I think, Beda, you're planning on doing different use cases for several of these sessions now?
Right. This was the Flexfield thing. The next time I could think about JSON table, how people use that for analytics, or Soda, how people use this Mongo style way of creating collections and documents inside the collections. I think I'll pick one of these topics, maybe a 10-minute introduction, and then we could do this. Yeah, I think I have.
And another question is, can we fix the JSON structure with certain fields and the type of data type for the fields in the JSON?
Yeah, we get this question actually quite often, and this goes into the direction of schema. Can I define a schema of my JSON? And although the question occurs quite often, we get a broad variety of answers if we ask customers what they really want. Most people say, hey, XML was way too complex. Don't repeat what XML did. So, I mean, XML schema, I don't know how many people of you use that, have these substitution groups, schema imports, inheritance, types, subtypes. It was super complex. If you had an XML project, first thing you needed was read a week or so before you could even start it. So this is why we're unclear. We don't have really clear requirements from customers what they mean with schema. One thing you could do is you could write your own PL SQL logic to check for examples that certain fields exist and are of a certain data type, or you could use JSON exists to do that. Maybe using a check constraint. So you could say, I want all my JSON documents to have an ID field. This is something you could easily express using JSON exists. And once you put that either in a trigger or in a check constraint, you would make sure that every document that gets inserted has an ID field. The question is just, if you have certain combinations, if my field's gender says male, then the shoe size has to be between 8 and 12 and something like this, then, well, why don't write this in PL SQL? Why invent a new schema language? So JSON has JSON schema for a long time now, and we don't really see huge pickup there. I mean, maybe people who work with JSON schema, if they have a different opinion, they can just say so, but I'm not sure what we're going to do there.
Thanks, Beda. And there's a comment from Nils. For those profile pictures that are not so big, you can save the picture as a base 64 encoded string and use that value directly in HTML tag. And I just thought I'd let you folks see an example of that. So here's a very small function, base 64 encoding. And I'm using the util encode package, base 64 encode function. So I'm taking the blob and pulling out pieces, casting to var_char2, constructing my clob, and that clob is then returned.
Wow, but you use substr to extract it, right?
Yeah.
Yeah.
So it can be done.
Yeah. So are you pulling it out of JSON data?
Not in that case, no.
Okay, got yeah. Because then I would, if you were using substr to extract stuff out of JSON, then
That's just a blob column in a table.
yeah.
All right,
Yeah.
let's see. Other questions. Can you discuss the use cases or pros and cons of using the DBMS JSON create view subprogram versus the create view SQL command to create your views?
Yes, I think DBMS JSON create view relies on the data guide. Is that correct, Imarin? Can you confirm that this question? Yes, perfect. So we've created another feature. That's also a feature that's actually could be shown here as a standalone feature. We called it JSON data guide. And what it does, it scans your JSON data and extracts information about all the field names and their data types. So if you have JSON data that you receive from a third party and you want to know what are all the field names, you could obviously look at a few instances and write this down yourself, but then you can never be sure that you didn't miss some fields. So this is what JSON data guide does. It scans your data and creates a structural summary information. So it will say, well, there is an ID, and it's a string value, and there's an age field, and it's a numeric value. It may also tell you what the ranges are. And we've added a package, DBMS JSON, which has a set of functionalities. One of them is called create view. So it automates the process of creating a relational view over your JSON data. Exactly. Stephen just posted the doc for that. So what I've shown here is just the manual steps, and DBMS JSON create view is just a layer on top, which will make the same stuff a lot easier. So imagine a JSON which has more than 2 fields, let's say several dozens. I mean, just a few months ago, we had a customer who had, I think, several thousand fields in their JSON, very sparse, obviously. And they've created thousands of views. Obviously, thousands of fields, yes, and they had different views. There's obviously 1,000 column limits, so depending on what angle they wanted to look at the data, they had different views. And yes, writing those view definitions by hand would be pretty long. So JSON create view might be a good usability feature. But under the cover, what JSON create view does, it creates a view definition using JSON table.
Thanks. All right. Any other questions, comments, your experiences with the JSON functionality? All right. This is awesome. Yes, it is.
Wasn't this the guy who said before, the person who said this was very buggy?
How in the world of 12.2 and 18C?
I'm just scrolling up. No, it was Lior. Yeah, very buggy. No, it's awesome. Cool. Very good. Yeah.
All right. Well, it looks like we've gone quiet on questions. Beda, you can certainly show some more stuff, but we don't need to keep going. We can just finish for today.
There's nothing I have prepared. I mean, I want to keep the other stuff for the next session. Otherwise, okay. I want to basically have every session to have one message.
Mm-hmm.
And Flexfield is something, maybe it doesn't excite too many people today, but it's a very common use case.
Mm-hmm.
It's a very common use case.
A classic fit.
Yeah.
All right.
Okay, thank you.
Thanks, everybody, for joining us, and hopefully you'll be...
Oh, there's one more question. Oh, yeah, this has been very cool. Thank you, yes. Thanks, Charlie.
We'll see you at the next JSON event in June.
Thank you.
All right. Thanks, everybody. Thanks, Beda.
Thank you.